maintainer track intro session for Kubernetes CNCF Conformance Working Group. To judge the audience here, how many of us have been involved in certifying at least one of the 79 certified Kubernetes distributions? Okay. So we are going to do this as an intro, but we really are available to go into more detail. And then tomorrow there's going to be a very interesting deep dive session, which is going to be much more of a working session of the working group to decide.
You're on.
Am I?
Yeah, you're on.
Okay. To decide, particularly around Windows conformance. This has been, in the 3-year history of the CNCF, I would argue the single thing that has had the most impact on the cloud native ecosystem. And it's something that I've personally been extremely involved in and am very proud of, and so we will walk through it. Thank you.
Yep.
Yeah. So the Certified Kubernetes program is a conformance program. It's actually a little unusual compared to most conformance programs. There's no third-party lab that you send things to. There's no big fee that you pay. There's an open source software conformance suite, which is a subset of the test suite already developed in Kubernetes. And it is a way for vendors to certify that their implementations of Kubernetes have not broken any critical APIs, that their specific, as we say, if you've seen a Roadrunner cartoon, Acme Kubernetes engine still implements all the functionality of vanilla Kubernetes. So we launched this just a little over a year ago, and we are now up to 79 certified Kubernetes platforms. This is what happens when you prepare your slides like 2 weeks in advance, is you fall back. And if we can just take a moment here, Taylor, can you stand up, please? So for everyone who always wonders, what happens when I, thank you, submit my results to GitHub, and who looks at those? It is all Taylor, and she's the one who does fantastic work, very politely saying, oh, you didn't quite get that right, or we had one today where it was saying, yes, you don't just need to upload the log of your test results, but they actually need to be passing. And she put it much more nicely than I did, and without any tone of sarcasm in her voice. But I really would compare this program to almost any other conformance or certification program in history, maybe up there with Bluetooth and Wi-Fi, in terms of the breadth of the industry that we've been able to pull in. That is, literally everyone has signed on to this program, and that there's some pretty clever aspects built into it that really discourage people from falling off the release train. So, yeah, we won't do every piece here, but the key parts are you need to be a member of CNCF or a nonprofit organization. So if you're just a community distro, that's totally fine. You don't have to pay anything. You sign a form. It has a lot of legalese in it, but it is hopefully understandable. It's like 3 pages long. And then you upload the test logs from your conformance results. So one of the key conditions is that it has to be the current release or the previous one, and if we have time tomorrow, I think we might consider relaxing that, where we're considering making it the past 2 releases, because to try and be a little bit more realistic about where people are. There's these ideas built into it. This is a little more complicated, but the idea behind it is to say that we don't want you to be able to take a super old version of Kubernetes and say, okay, this is now conformant, and just stick there. And having done a conformant version, we don't want you to just be able to stick there either and say, oh, see, we're conformant forever. And so we have a carrot and a stick. And the carrot is both the certified Kubernetes logo, but also the ability to use the word Kubernetes in your product name. So you can be called Acme Kubernetes Engine or Acme Kubernetes or things like that. The stick is that you need to keep recertifying newer versions in order for your older versions to stay conformant. So at least in principle, if you just decide that 1.13 was going to be the best and only version of Kubernetes ever, you can certify that, and you don't have to certify a new version until 1.17, 1.21, and 1.25, but you actually do need to do those new versions and offer them for sale. And so it really is trying to avoid this fear of people, and something that we've actually seen in other programs in the past. And then maybe the most clever and kind of most subtle aspect of the conformance program that's had the biggest impact is that it's not just an assertion where you can say, okay, well, fine, in theory, somebody says that they passed, but I could have just copied somebody else's results and posted it up there. How do I actually know that you're conformant? And here's where we've built in what's essentially a crowdsourcing element to how it works, that any of your customers can come along later and you've given them the exact steps in terms of flags or configuration and such in order to replicate these results, and they need to be able to replicate them and find out that your implementation is still conformant. Now, in reality, if they come along and they get an error message, we don't instantly take away the conformance. There's all sorts of bugs that can occur and incompatibilities and other sorts of stuff. So there's an appeals process, but any end user is very welcome to escalate an issue to the Kubernetes Conformance Working Group. We would then work with that vendor. But it is definitely the case. There is I'd say, universal consensus among this working group that if a vendor had claimed conformance and was not actually conformant, that they had changed something in the production environment, that they were now failing a test, a test that the SIG architecture, I'll say, felt was a valid test of Kubernetes conformance, that we would decertify them, and they would then no longer be able to use the trademark. And if that happened, it would actually be pretty big news. So this is not like highlighted on the web page or anything, but I think it's just a really critical aspect of how the program was designed. Yeah, I think I hit this. So for CNCF members, it's free of charge. If you're a little startup, it's $7,000 to become a CNCF member. If you, for whatever reason, are opposed to being a CNCF member, you're welcome to just pay and certify. It's the same $7,000 either way, and free for nonprofits. And I'll take a question, and then I'm going to hand it off.
Yeah, so are you certified by company or by product, or both?
It is certified, so you're certified by product, and any member of CNCF is welcome to certify any number of products free of charge. And we have at least a couple cases, Huawei and IBM in particular, where they've certified both their public cloud product and their private cloud. I think there's one or two others where they've certified two. It would be a little odd to me if they were going to do more than that, just because if it's confusing for us, it's probably even more confusing for their customers. But they're welcome to do as many as they want. So I'll stop there. Thanks very much, Aaron.
All right. That's all good.
Yeah. Sorry, one more, if you don't mind.
Sure.
Yeah, so I did have a question on the version. So
Yeah.
given that there's two versions behind, I know you're starting listening at them. One thing that I'm concerned about is that if someone has a given OS release that, let's say, they're subject to regulatory approval around these, your financial or whatever, it may take you a year or 2 years to get a particular thing certified. And so what my concern is if your operating system that you've certified in your environment is going to take you that long to certify, I think you have to get that deployed first, then you have to get Kubernetes on it. Now you're looking at 3 or 4 years of Kubernetes behind. So
the operating system's decoupled from Kubernetes. So you can run Kubernetes on old versions of RHEL in particular. But to sort of get at what you're asking with the question, if you certify a version and then you keep certifying at least one new version per year, the old versions remain certified. So, yeah.
require a new OS version? Like, let's say people say, hey, this GPU thing is so awesome in 3 years, it's mandatory, and it needs a new kernel module. I mean, I'm not
Are you ready to make the GPU kernel module mandatory, or think SIG architecture is?
We're going to quote me on this, right?
It seems silly. I'm just
No. It's a totally fair.
I feel like it's a super legit use case, and my suggestion might be to defer that discussion until we've had time to really think it through in the LTS working group as part of the Kubernetes project, because I think that's the CNCF here is really about making sure that the qualification and certification process makes the most sense and meets users' needs. And I think the actual set of requirements and set of distinct users still needs to be hashed out there, because we do care very much about that regulatory concern, but it's about how do we best balance off those like long lead times with what it is we're trying to accomplish. And your example of like a newer version of Kubernetes versus a really old operating system might be kind of a hairy situation. Yeah, so.
And what is the oldest Kubernetes that is still getting security releases?
So the security release process matches the number. It's 3 releases back. So 1.13 is out. 1.10 is the last release of Kubernetes, or the earliest release of Kubernetes that still gets patch releases.
And
right?
so I would emphasize that fact, though, although vendors in principle could be supporting 1.8 or 1.9 or such, and there is a direct analogy to Linux here of concerns about are the fixes really being backported or not.
To be clear, that 3 releases back that I'm talking about is what we're suggesting we have the conformance certification window match, because it just seems to make sense. If the project's willing to support it, that seems to be a sane window for certification. Mike, hang on. Let's use our microphone voice.
For the GPU use case in particular, I think that we'll probably solve that with a optional profile to avoid basically that coupling that you're trying to that you don't want there. And I think just in general, just to echo what Aaron said, the work group does care about that use case. So probably the best thing to do is, if you're interested, just join the mailing list and participate and let us know if something's kind of falling through the cracks. We're certainly not trying to cut that out. And so if we are inadvertently, then we can revise that, I think. Yeah.
So I'm going to hand it off. Thank you.
Yeah, thanks. You can just set that on the table, I guess. How do you actually run the conformance tests? There are 2, I know, the way to leave me with the easy stuff, Dan. There are 2 different ways that are documented. You could maybe use a couple different ways, but the idea is the tests themselves are the same tests that the project uses to test itself. They are authored by the project. They are owned by the Kubernetes project. These are 2 utilities that make it maybe potentially easier to run them. KubeTest, the first one, is very rich and configurable, shall we say. It's what we use in the project's CI right now. So the top line just is a go get. For those of you who use Golang, this should be pretty easy. And then inside of the Kubernetes directory, you are making just the binaries you need to make, which is the end-to-end test binary, Ginkgo, because that's what we use to run the tests, and then kubectl, because there is some client interaction with the server. There's some environment variables just to set up like the path to your Kubernetes config and saying, yes, we're running a conformance test. And then I've got 2 options here to run the conformance tests. The first one is the most boring option, and I think it's actually what the second, what the Sonoboy path does. And that's just runs all the tests in serial. So it runs every test with the text conformance in it. And it takes about 1 to 3 hours because it's running every single test, one after the other. And some of those tests are exercising things like exponential backoff and reaching maximum delay. Another perhaps faster way of doing it is to run the tests sort of twice. Once you run just the tests that have to be run serially because they're disruptive. And then you also run in parallel the rest of the tests, right? And that method, it's probably larger numbers now, but when I did this a couple months ago, it used to be I could run in parallel, like in 6 to 8 minutes, I could run most of the conformance tests. And then it took like another 3 to 5 for the serial tests to finish. So that's just a really great way to do it locally. And like I said, we do this in the project's continuous integration infrastructure because we need this level of configurability to support all these sundry clouds and ways that you can deploy Kubernetes. So you're seeing a lot of flags that are actually used to configure a lot of different things. And this is just the set of them used for conformance. Perhaps the more human way of doing this is just well, we like containers so much, what if we just put the conformance tests inside a container and then we ran that container? And what if we had a cluster that's all about running containers and we just ran the container in that? So you can actually run the conformance tests as a container inside the cluster that you are testing. That's basically what Sonobuoy does. Sonobuoy is the command line that sort of orchestrates all of this. But behind the scenes, it schedules a pod and a couple other things to watch that that pod is doing what it's supposed to, and the pod does all that gobbledygook I showed you earlier. This is really great. It's super user-friendly. It's basically just these 2 lines. It's super easy. That said, I do sometimes wonder if this is the most realistic depiction of what conformance would mean to me as an end user, because I don't know about y'all, but when I use a Kubernetes cluster, I don't crawl inside one of the machines and use it from there, right? Like, I actually use it from my laptop, where I probably have a little bit of network in between me and the rest of the nodes. So it's important to me that we sort of support both of those use cases, but this is an extremely concise way of doing it. The other thing I'll mention about this is that Heptio built Sonobuoy. They also built the image that has all of the gobbledygook packaged up in there because they needed to do it super expediently. We'd really like to see if we can't have the project actually own this image instead, because if the project owns the definition of what the tests are, sure seems like the project could package up the definition of all of those tests into an image. We had work started on doing that in 1.13. I actually don't know authoritatively whether or not it landed by default as part of 1.13, so maybe it did. If you're watching this, maybe you can go verify, but I can guarantee it'll be done by 1.14 since I'm leading that release process. Question, yeah, we're doing questions in the middle of this.
Does it actually run the same E2E test binary inside, or does it compile it separately?
It runs the same E2E test binary inside. Yeah, that's, I suppose the other thing is Sonobuoy only cuts releases like on release boundaries, whereas KubeUp kind of recompiles everything. So that's how we use it to keep track of conformance tests as they are added along the way, whereas Sonobuoy tends to be released like right on a release boundary. That's why, for example, the kubetest way of standing up a cluster is what got the first certification for 1.12, because Sonobuoy had to wait a while to cut the appropriate image for 1.12 certification. So Sonobuoy, the utility itself, I'm not sure I want to be an upstream dependency, but the image that it schedules to run the conformance tests is what we did. We started work on that. Like the code, DIMS actually landed some of the code to build that image, but fully integrating it into everything and as part of the set of release artifacts that we provide with Kubernetes. I'm not sure if we actually got that far by default. So yeah, I think I already talked about this, and then Sonobuoy also has an option to just extend the timeout. If you don't have that option of running the tests in parallel and serial, maybe you're just gonna have to wait longer. Maybe you have like a really flaky network connection, or you have to download all of the container images, that sort of thing. I also wanted to talk a little bit about the progress we have made in like what does conformance actually mean. So conformance we define as a set of tests that interact with the cluster as an end user would, so that it's a set of end user behaviors visible as an end user would see them. And we've been working on trying to improve the set of behaviors or use cases that we're exercising. And so part of that is, well, how do we actually add the tests? Part of that is how do we know, like, have we comprehensively covered all of the behaviors? And part of that is making sure we're going after the right behaviors first. So this is just updates on our progress over the past 3 releases. Just to toot my own horn a little bit, I started working on this in earnest in V1.12. So that's why I think we moved from 4 new test cases being added to 22 new test cases. It's not like I wrote them all myself. In fact, I didn't, because it's the job of the feature owners to write tests for their features, not just write their features and throw them over the wall. So they wrote some new test cases, but we actually needed to review them and make sure that they fit the list of conformance test requirements, which shockingly weren't actually documented and set in stone until the v1.12 release. It took us about 2 months to figure out what we wanted for conformance test requirements. We needed to make sure that we had a list of requirements on like what the actual features are that are testable for conformance. You know, things like they should be stable, they should be enabled by default. They probably should not be optional. They probably should not be the sort of thing that's dependent on hardware or certain clouds existing. We also needed requirements on what the test itself did. So like, was the test doing some sort of anti-pattern, like depending upon events which don't have guaranteed delivery? Or was the test doing something really disruptive that would cause other tests executing against the cluster to fail? So after that, we decided to find ways to measure whether or not we were headed in the right direction. We didn't actually have a good way of measuring behavior. Behavior is a pretty abstract concept. So what if we instead focused on API coverage and also look at something like code coverage? Code coverage you're pretty familiar with from unit testing, but what if we could do the same thing with the end-to-end tests that we run as conformance tests? Question?
So just after that, does the conformance test only focus and emphasize just API type of test, or does it also look at load test, pod density, scale?
At present, we don't look at performance-based metrics.
Mostly on the API.
Right. That could be something that could be like an optional profile, because we want to make sure that Kubernetes is capable of working on a cluster of Raspberry Pis as much as it is on a 5,000 node supercomputing cluster. But it could be that the person who has the amount of money to stand up a 5,000 node cluster wants to put a sticker on it that says, we guarantee this is really, really fast and super performant. And there are certain use cases that supports that a Raspberry Pi cluster doesn't. But at present, no. Pat, okay, so just the process to add tests, I think I tried to sort of walk through some of the requirements. The little asterisk there is because I have lots of slides on very detailed examples of each of these requirements. But around all of that, you write an end-to-end test for your feature. This is just kind of what you should do during development anyway. Then you should document what that end-to-end test does. Yes, developers, you must actually document your code. And then after it's demonstrated to meet the requirements of like being well written and not doing anything in a flaky manner and using the appropriate set of features, propose it to SIG architecture, that it be promoted to conformance. So why SIG architecture? SIG architecture is the special interest group that most appropriately defines what Kubernetes is. They have a number of sub-projects around like how do we add new enhancements to Kubernetes through the KEP process. How should we organize the code in the code base through the code organization sub-project? And also, what are the full set of things that make the most sense for conformance? The list of people who can actually make that decision is small right now, and we are looking to grow it. And part of growing it is going through this process a lot and having people review these tests and make sure we've got all the requirements written down to the point where it's not just like a very thorough review by a person, but going through just a pretty quick and easy checklist. Did you still have a question, Patrick?
Yeah, the second bullet point, document what does that mean?
I don't know if I have an example here. So basically, the idea was some of the tests as written today are like a couple hundred lines of code that's super verbose because that's just the way Go's formatting works. And it can be difficult for someone who is non-technical to, at a glance, read that test and quickly grok what it's trying to do. So what if we instead had like a 1 to 3 sentence description that tried to describe like what's the setup, what's the logic being executed in RFC 2119 compliant language, you know, the one that's like must in all caps, should in all caps, and those actually mean things, like use that kind of language so it sounds really formal, but those actually use well understood definitions for those things. And then from that, we can use a tool that generates a set of documentation that's like, these are all of the tests, and this is what they do. So you can kind of get close to that, what does conformance actually do thing. It's not perfect. I would really like to find ways to improve on it. We can talk offline about how to do that, but that's roughly what it is today.
Where would the user get this?
It's in the conformance requirements. It actually specifies the format that you're supposed to do the comment. So it says something about where the test name is supposed to go, what release the test was added in, and then what the description is supposed to be. So here in graph form is the number of conformance test cases that we have added to the Kubernetes Conformance Test Suite over the past year. This is a little out of date because it was before 1.13 was cut, but it's basically the same number of tests. It's cool how it goes up and to the right. Here it is in text form, and I'm basically just showing this to demonstrate how, if you want to read these slides later, because they're posted online, you can see all the exact tests that we added. But I was pretty happy with the fact that the text actually overflowed the slide. We added so many in 1.13. That was really great. And the bulk of the tests were around kubectl client, which was also great. End users do often use kubectl, kubectl, if you will, to interact with Kubernetes clusters. However, that progress maybe doesn't look so great if you look at the number of conformance tests relative to, say, the number of tests that we use to block the release. And this isn't even actually the full number of tests. This is just the tests that run in one of the 30 or so jobs that could potentially block the release. These are all of the tests that are non-disruptive, non-flaky, non-slow, don't exercise a feature that's optional or beta. And you can see there's a lot more of them. So it could be, like, what if, for example, in a perfect world, we just used all of those release blocking tests and said, well, if you're blocking the release with it, it may as well be conformance, right? It turns out, if I look by API coverage as one of the proxies for behavior, that those release blocking tests don't really add a whole bunch more coverage. It's like it's an entire extra 10%, which means maybe there is some room to grow, maybe there are some features to grow. But it also means like there's a whole other 40% that's not being covered right now. All right, this graph is kind of colorful. Let's actually explain it a little bit more than that. So each of the colors signifies a color of the rainbow. No, a release. So the red one is the latest release, and then the cooler you get, the older you get in the release. And then going down the graph, we can see that the very top entry is the API coverage for every single API endpoint available. So by API endpoint, I mean a path and a verb, like post to API v1 pods foo. Then instead of focusing on all API endpoints, what if we just focused on the stable API endpoints, which are unchanging and is one of the requirements for conformance? And then beyond that, what if we focused on the stable core API endpoints? So core means things like pods, things like namespaces, things that might end up in the nucleus layer of Kubernetes if you've seen that architecture diagram. They're the things upon which all the other pieces of Kubernetes are really built. Like you can't really have a deployment without a replica set. You can't really have a replica set without pods. You can't really have services without endpoints, things of that nature. The lower three tests are the release tests instead of the conformance tests. So like I said, I don't think they provide a ton of additional coverage. The other thing I wanted to denote with the colors is that yay progress as you go down, as we release more things, we get more coverage. We are making progress. This is good. Here is this in a much shinier graph. This is generated by API Snoop, a tool written by hippie hacker over here, contracted by CNCF over there. And the sunburst graph sort of shows the inner ring is the level, the outer, the second ring is the API group, and then the ring beyond that is all of the different names or verbs. This basically shows that if we just look at the conformance test and we only looked at the endpoints that we hit on a Kubernetes cluster from the end-to-end test, we only get 14.3% coverage. That's really not that great. But it turns out like there's a lot more API stuff happening than just the API calls as a result of the end-to-end test binary. This is why we don't think it's a great idea to just look at like, well, if I analyze from my laptop, like what am I calling? Then if I've called all the things from my laptop, I've covered everything. There are actually some things I can't cover from my laptop at all. So if we look at potentially all of the API coverage from every potentially qualifying test, so like let's assume all of the release tests qualified, that's sort of the delta that we would get with this graph. It looks better. It's up to 43.3%, but we still have a lot to cover. We still actually need to write more end-to-end test cases. So how you can help? You can help contribute tests that exercise pod functionality. Because I jammed 3 talks into one in this, I guess I kind of lost the flow here. But suffice to say, one of our priorities from a conformance perspective as we look to improve coverage is we want to make sure that the pod, the fundamental building block of Kubernetes, is what we have the most coverage on. You can change your network. You can change your runtime. You can change your storage. But a pod's got to work the same way every time. So we got to make sure that all of those behaviors you expect from pods, from the container probes that monitor them, to the way volumes work within them, to when they start and when they die, and the sidecar stuff works all okay. Like, we have to make sure all of that works. You could also help by categorizing the existing set of tests that are labeled with conformance. Some of them don't meet the requirements in that finely detailed list I listed out. You could run conformance tests against your own Kubernetes cluster. You might find there are places where it's not working in your cluster, and we can have a discussion about whether that means your cluster is configured incorrectly, or maybe it shouldn't be a conformance test. Great example of this is those folks who've had to run conformance tests in air-gapped environments. That is a totally valid use case. We had to figure out how to make that work. You can participate in discussion at one of the 2 main groups that talks about this, the CNCF Conformance Working Group, which is what I'm talking to you about now, or SIG Architecture, which is the project group that is in charge of this. Here are some references on all of that if you want more. Thanks to these folks whose content I largely pirated, or who helped put together the program that I am talking about right now. And thanks to these folks who helped put together many of the graphs that I just showed you. And I think I've already run out of time.